All right, Chem 11. Today I'm going to be going over some problems from the handout, limiting reagent and percent yield problems. The worksheet is on your D2L site for the class. Of course, as always, to do these questions, I need the periodic table 3000 Mendeleev edition, and of course the Calculator-O-Matic 3000, the solar powered edition. All right, so when aliens come back to Earth and they knock down all the power because we use their gift of the internet for TikToks rather than the advancement of science, this guy will still be able to do chemistry. Anyway, so I'm going to go through a number of problems here. Now, the limiting reagent percent yield handout had 8 problems on it. I'll try to get through a good bunch of them. I don't want the video to be like 5 hours, but I'll go through several of them and then you'll probably get it. It builds a lot on our stoichiometry and knowledge of limiting reagent, which we've already done. There's a video that explained that, and I know I already did one that did a number of practice problems for that as well. So we'll start off with one of those and then we'll get into the percent yield one, okay? So let's do number 1. Actually, let's do number 2, because number 2, I have grams and I have to convert it. So we'll do number 2 first. So this is number 2 on the sheet. And number 2, the equation is magnesium plus hydrochloric acid. Looks like a single displacement. Magnesium is stronger than hydrogen, so we'll get magnesium chloride and hydrogen gas. All right. And in this one, it says we have 7 grams of that, 9 grams of the acid. And the first thing it wants us to do, this is 2 parts. The first part, which I'll do in green here, if it's still good, let's see, green, is we will do the limiting reagent. All right, so the limiting reagent. So again, I want to compare these 2 quantities. I've got 7 grams of magnesium, 9 grams of hydrochloric acid. They're going to get used up and start forming these products. Now, one of these will get used up first. Whatever one I get that gets used up first, that's my limiting reagent. That's going to stop the reaction, and that will mean the end of product making, and whatever I've got, that's it. I've reached my maximum yield of product. The other one will still have some left over. That's my excess reagent. All right, we've done problems with both of those. Anyway, so first thing I got to do is I got to relate these 2 things. Oh, actually, the first thing I got to do is make sure my equation is balanced. We'll put a 2 right there. Always have a balanced chemical equation. It looks like we're pretty good now, right? This is using my molar ratio. If I had forgotten that, the whole question is done for, right? Anyway, I'm going to divide these by their molar mass. All right, so I'm dividing each substance by the molar mass. That's where the periodic table comes in. Magnesium is 24.31, and then when I add an H and a Cl together, and again, it's not 2 H's, not 2 Cl's, just H and Cl, just the formula, I get 36.46. All right, divide those out. The Calculator-O-Matic will spit out the numbers for me, and I end up with that. Now, for limiting reagent, see, now I have them in moles. I can relate them to each other, right? Because we know we have 1, 2, 1, and 1 here. That's the relationship between all of these amounts, all of these substances, and it's in moles. So now I have moles here, and I can do it this, I can relate things the same way. So I'm going to bring this over and say if I use up all 0.29 moles of magnesium, how much HCl would I need? All right, so I multiply that by the mole ratio when I bring it over, and that mole ratio is going to be 2/1, and that will mean that that is 0.58 moles that I'll require. So again, here's how we interpret this. I turn both of what I was given into moles. This is what I got, all right? the stuff that's underlined in red. That's how much I can work with. I can't work with more. So to burn off all the magnesium, all 0.29 moles of it, I need 0.58 moles of hydrochloric acid. I don't got 0.58 moles of hydrochloric acid. I only have 2.47. So for all of this to burn off, I'll need 0.58 of this. I've only got 0.24 of this. I don't have enough of the hydrochloric acid. That makes it my limiting reagent, and the magnesium is my excess reagent. All right. All further calculations, and again, common mistake. Now I've got two mole amounts here. One is what I actually got, the other one is what I actually need. To figure out the product, because part B is going to ask about one of these products, I have to make sure I use my limiting reagent, and it's what I got of it, what I have of it, right? Anyway, so I'm going to bring this over. This is my limiting reagent, and it wants to know the maximum yield. Part B is, what's the maximum yield of the hydrogen gas? So when I bring my moles over, it's going to be 0.247 moles. I'm going to multiply it by the mole ratio. And in this case, it's going to be 1/2. And when I do that, basically it's cutting it in half, and I'll end up with 0.1235. And that's moles of the hydrogen gas. All right. I got to get my grams, so I'm going to multiply by the molar mass of H2, which is on the periodic table 1.01, plus another 1.01, the atomic mass of hydrogen. If I add two of those, it's 2.02 grams per mole. And when I multiply that, I will get 0.25 grams of hydrogen gas. And that is my answer for B. All right. So A, hydrochloric acid is my limiting reagent. For B, I'll get 0.25 grams of hydrogen gas as my maximum yield for that. All right. So that's number 2. Let's do some percent yields now. This one didn't have percent yield in it. This one was just limiting reagent, but it's good to review this stuff. All right. Pause the video if you need to get that down or take a second look at it. I'm going to set up our next couple of questions. All right. So 1, 2, and 3 on that sheet were all just limiting reagent and maximum yield questions. From 4 on to 8, those were ones that involve percent yield, and that's the real reason I'm doing this video. So let's do one of those, all right? We'll do number 4. Number 4 looks like we have calcium carbonate decomposing, and I know this one's a thermal decomposition, so I'll put that there. You did not have to put that there, but I know how this falls apart, so we'll put it there. So calcium carbonate breaks down into calcium oxide and carbon dioxide. So I have 60.1 grams of this. When it broke down, I got 15.1 grams of that, and that is my actual yield. That's what I actually got when they did it in the lab. It says in the question. And it wants to know what is my percent yield for this. So if in the lab I take 60.1 grams of this, and I actually got in the lab 15.1 grams of the calcium oxide, then what is my percent yield? So what I have to find here is my theoretical yield, right? My perfect or ideal yield that has no loss involved in it whatsoever. And I do that through calculation. Again, I can't relate any of these things until they're in moles. Now this equation is kind of easy because it's already balanced for me. So all my mole ratios are just going to be 1/1. So let's turn this into moles by dividing by the molar mass. The molar mass for calcium carbonate is 100.09, and that will give me 0.60 moles. I'm then going to take that over here, multiply it by my mole ratio, which is nice and easy now. It is 1 over 1. And that will leave me with 0.60, the number doesn't change, moles, but now it's moles of calcium oxide. I'm going to multiply that by the molar mass for calcium oxide, which is 56.08 grams per mole. The moles will cancel, I'll be left with grams, and that will be 33.65. All right. Now I'll see if I can squeeze this into here. So now I'm going to figure out the percent yield. This is my theoretical. This is what I worked out with stoichiometric calculation. It assumes no loss. It assumes every single little molecule of this turned into as much of this as actually possible, but we know that that's not possible, right? There is some loss involved, and we went over that in the percent yield video. So now I've got the two things I need, my theoretical yield and my actual yield. I can do percent yield. So percent yield is equal to actual over theoretical. This is going to be tight. Times 100%. All right, so I always show my formula. Actual yield over theoretical yield times 100%. And my percent yield, my actual is the 15.1. My theoretical is the 33.65. It looks like they didn't do a very good job in this lab. They had quite a bit of loss. When you think about it, the most they could get was 33, and they only got 15. That's less than half. Sometimes it happens. They might have made a mistake somewhere. Right? Or as Bob Ross would say, there are no mistakes. There are only happy accidents. Happy accidents in chemistry can get you killed or fired. So no happy accidents. That's why Bob Ross was a painter, not a chemist. Anyway, divide this out. It's a very poor percent yield, only 44.87. So if I was running this experiment, that's what I got. I checked for impurities in this substance, see if it was actually pure, or I'd be looking at my equipment and seeing if something was damaged, or if I just made human error and mismeasured something. But that's number 4 done. Nice and easy. 44.87%. Somebody out there had asked me, sir, I only got 44% or 45% for one of my percent yields. Is that possible? Yeah, I mean, there are mistakes sometimes made in the lab or faulty equipment, and you get these crappy, right, percent yields. It happens, right? Your job as a chemist now, if you got this the first time, is to make sure you don't get it the second time, right? You'd have to find out where your mistake was made. Anyway, pause this video right now if you want to get this down. I'm going to set up our next question. All right, next question. Let's do number 5. All right, number 5 talks about that compound combining with hydrogen, and we get this, a very odd reaction. And to balance that off, this reaction was given to you in the question. And it said we had 0.112 grams of this. And it said our actual yield of the water was that. And so now let's figure out what our percent yield is. So it says, hey, we run this reaction. We have 0.112 grams of the hydrogen gas. We're assuming in this question, because they never gave us anything here, that this is in excess and that the hydrogen is my limiting reagent. So because they gave me nothing here, we assume they've got a ton of this, and this is the one that we'll run out of, the one that they actually gave me data for. So I'm going to divide by the molar mass for that, and the molar mass is 2.02. Remember, it's just the 2 hydrogens. That 4 will be used in the mole ratio. So grams divided by grams will be no grams. I will be left with moles. And when I do that, it is 0.055 moles. That's how many moles of hydrogen gas went into the experiment. I now bring that over to my water. Oop. That's a common mistake that I almost just made right there. See, I have this 0 here after the decimal. It's 0.55 after the decimal. I almost put my 5 there, but I caught myself. And I don't know what that is. I'm sure there's a psychoanalytic name for it, but I almost did it. And I see students do it quite often as well. Mole ratio looks like 4/4 to me. So that number is going to stay the same. Now it's moles of water, and we're going to multiply it by 18.02 grams per mole, because if I take 2 hydrogens and an oxygen, that's what I'll get using the periodic table. Multiply those together, and I'll get just under a gram of water being produced. All right. This is my theoretical. So I have my actual that was given and my theoretical that I just calculated. Calculations assume no loss. So now I can do my percent yield. I'll do the percent yield over here. Should be able to get it in. So actual over theoretical times 100%. My percent yield is equal to my actual 0.745 grams, my theoretical 0.99 grams times 100%. Before I just figure this out, I just want to point out one thing. See how my actual is a lower number than my theoretical? That should happen every time. The two might be close, but my actual should always be smaller. My theoretical should always be larger, because the theoretical is the perfect or ideal yield, right? So make sure, if I had done this out and I get 0.6 something or 0.5 something, I made a mistake, because I can't have that as an actual and get, in a perfect situation, get lower than that, right? So just be aware of that when you're doing these. And when I multiply that, the grams will cancel out, and my percent yield is 75.25%. It's a pretty good yield, not too bad at all. All right, so there's our answer right here for number 5. Easy enough? Yeah, these aren't too bad. All right. Let's do I'll skip 6. Let's do number 7. Number 7 has a little bit of a trick to it. All right. Number 7. All right, number 7, C3H6. So it takes a hydrocarbon. Looks like a complete combustion reaction. And I know it's complete combustion because I only have carbon dioxide and water. I don't have any solid carbon. I don't have any carbon monoxide. So, got to balance this one off. 2, 9, 6, and 6. All right. Information that was given to me, I'll put that in red. It said I have 91.3 grams of this. It did not give me grams of this, so we can assume that that is the excess and that this is my limiting. So I'll use the moles of this to determine something over here if I have to. It said for carbon dioxide, I got an 81.3% yield when I did it in the lab. All right. Now my actual yield, it doesn't tell me. In fact, that's what the question wants. It says, look, 91.3 grams of this fuel were burned. When we measured for the carbon dioxide, the percent yield was 81.3%. What mass of carbon dioxide did they actually get in the lab? So we're looking for the actual yield. So a little bit different here, because we're used to this one being given and finding this. Now we're given the percent yield and have to find the actual. The only thing I can start with is here, because I'm going to use this to bring it over to find my theoretical yield. So I have to turn this into moles, because I can't relate any of these things until this is in moles. I use the mole ratio, not the mass ratio. So I divide by, if I add 3 carbons and 6 hydrogens, it comes out to 42.09. Whoop, 42.09 grams per mole, and that's 2.17 moles. I'm going to bring that over here. 2.17 moles times my mole ratio. Now my mole ratio here, head over heels, 6/2. And that's going to equal, I'll put it over here because I'm going to use this space down here. That will equal 6.51 moles of the carbon dioxide. Then I'll multiply that by the grams per mole for carbon dioxide, which is 44.01. Again, I'm adding a carbon and 2 oxygens. So I get this. I got to turn my moles into grams, which I will do by multiplying by the molar mass. And I get 286.5 grams of CO2. I know it's under the H2O, but I'm trying to get it all on one whiteboard here, so I use this space over here. So this is my theoretical. All right. So I've got my percent yield. I've got my theoretical. I have to find the actual yield. The formula for percent yield has 3 variables, right? It can have different percentages, different actuals, and different theoreticals. So to solve for any one of them, I need the other 2. I've got percent, and I've got theoretical, so I can find my third one, right? If I have 2 out of 3, I can find the third, and I have that now. So let's start with our formula. Always show the formula. My old teachers back in the day, they said, if you show your formula, you automatically get a mark because you show me, you know what formula to use, right? Your numbers could be incorrect, but that's all right. You showed me, at least you. So I'm putting my 81.3% here. The actual I have to find. The theoretical I calculated. Always able to calculate the theoretical. Times 100%. All right, so what I'm going to do here is I'm going to isolate my actual. First thing I'm going to do, I've got multiply by 100%. I'm going to divide both sides by 100%. When I do that, these percent signs will cancel out. And 81.3 divided by 100 is equal to 0.813. And that will be equal to my actual over 286.5 grams. And so now to solve for this, my actual, I'm going to move it over here because I want to keep it all on one whiteboard, but normally I would do it underneath. My actual now will be equal to me multiplying these two. So 286.5 grams times 0.813. And my actual, when I do that, will be, there's nothing to cancel the grams out here, so I'll keep that. And it will be 232.9 grams. All right. And the reason that works is actual is divided by here, so I would multiply both sides by 286.5. And that's where this shows up here, okay? Just so you know where it's coming from. I know it's simple math, but every so often simple math seems tricky because you're thinking chemistry, it's got to be hard. All right, so there's our answer for number 7. Pretty easy stuff, right? Nothing too hard there. All right? Mole ratios, changing moles into mass and mass into moles, easy stuff. Putting it all together, hopefully it's clicking inside of your brain right now. Let's do number 8. So right now, if you have to, pause the video and get that down. Or take a look at it. Make sure your answer is the same as that one. All right. Number 8. Number 8 has two parts. 8A. Number 8 says, what is the percent yield? And it gives me the actual values already. So it's pretty easy. 8A. I'm going to shorten this up because you know what these mean by now. And for 8A, it gives me the values. So my actual yield, it said was 3.615 grams. And then it said the theoretical was 4.214 grams times 100%. And the percent yield is equal to my grams divided by grams cancels. Multiply that by 100%. And it's a pretty good percent yield, 85.79%. So 8A, really easy. Didn't have to, figure out a theoretical yield at all. Didn't have to do any calculation except for just dividing those and multiplying it by 100. B. I'll do B in a different color actually, so they stand apart. B. So B is like the one we just did. It actually gives me the percent yield, and I have to find the actual again. And it doesn't equal. It is multiplied by 100%. So this time it says my percent yield is 63.5%. Not bad, not great either. My actual is what we're looking for. I'll actually write the word actual this time. Times 100%. And my theoretical yield, which I'll put under that, is 4.214 grams. And so now I have to do the steps. So I want to get rid of this. So if it is multiplied by 100% here, to get rid of it, I do the opposite to both sides. Those will cancel, and that will be 0.635, and that will be equal to my actual over 4.214 grams. I've switched colors on you, and I'm not sure why. Anyway, the next thing I have to do is I have to bring this over to here. On this side, it's a divisor, so we're dividing by 0.424. So on this side, we will multiply both sides by 4.214 grams. These two will cancel out, and my actual will be equal to 0.635 times 4.214 grams, and my actual is equal to 2.676 grams. All right. And that's it. That's my answer. Anyway, percent yield, one of our easier types of calculations to do. I hope everything is crystal clear for you here and that you understood it all. If you didn't, throw a comment in the comment section of this YouTube video down below, and I'll get back to you right away. Or if you're in my class, reach out to me through Edsby or whatever else. All right. Anyway, limiting reagent, percent yield. Hope it made sense. Hope it's crystal clear for you. Get to work. I'll talk to you soon. Bye.